All right, let's look at number 9. We're asked to find the vector in component form and in linear combination form. So our vector is RS, which means we start at R, that's our initial point, and we go to the terminal point S. So to find the coordinates in component form, we simply subtract the 5 minus the 3, that's terminal minus the initial, and then 7 minus -1. Again, that's terminal minus initial. So then we do 5 minus 3, which gives us 2, and 7 minus -1 gives us the 8. So the vector in component form is 2, 8. And then in the linear combination form, which is just I and j components, it'll be 2i plus 8j. Now, to illustrate what that means is we start here at point R, which is 3, -1, and we go towards point S, which is 5, 7. And this vector, going from R to S, is a vector that goes over 2 and up 8. And that's what the 2, 8 is representing. All right, for number 10, we have vector going from A to B, where A is 3, -5, B is -9, -3. And again, all we do to get it in the component form is do the terminal minus the initial. So we start with -9 minus the 3. And then for the y values, it's -3 minus the -5. So -9 minus 3 is -12. -3 minus -5, which is the same thing as -3 plus 5, would give us 2. So -12, 2 is our vector in component form, and then in linear combination form is -12i plus 2j. Okay, number 11, we have a vector whose magnitude equals 14, and magnitude is indicated by the vector with the 2 bars on either side. So the magnitude is 14, and the direction is 307 degrees. We're asked to write this in component form or linear combination form. So let's do the component form here. That means we need to find A, B. A is r cosine theta, and B is r sine theta. So r cosine theta would be 14, that's the radius, r, times the cosine of the angle, 307. You'll put that in your calculator, and you'll get 8.4 approximately. So that's A. B is 14 times the sine of 307. You put that in your calculator, and you'll get -11.2 approximately. So the component form for the vector is 8.4, -11.2. And then in linear combination form, it's 8.4i minus 11.2j. Okay, and here's number 12. We have the magnitude of this vector is 53. The direction is 317. And so component form A, B is A would be r cosine theta, and B is r sine theta. And that would be 53 times the cosine of 317. And that's approximately 38.8 from the calculator. And B is r sine theta, which is 53 sine 317. And your calculator will give you -36.1. So the component form is 38.8, -36.1, and then you have the linear combination form of 38.8i minus 36.1j. In number 13, it says find the magnitude and the direction for each vector. All right, so vector B is 46, -19. First, we find the magnitude, and the magnitude of the vector is the square root of the first coordinate squared plus the second coordinate squared. I just ignored the negative on the 19 because I know when I square it, it'll be positive anyway. But that could certainly be -19 squared here. So we take the square root of 46 squared plus 19 squared, and that gives you 2,477. Then we'll take the square root of that, and we get approximately 49.7. So that is going to be your magnitude. Now, as far as the direction goes, you'll want to draw a triangle. So we know we would go start at the origin, go to the right 46, and then down 19. And of course, again, I just ignored the negative that's on this 19, because all I'm looking for is distance. So over 46, down 19. You then want to find the alpha that is in this right triangle here. And so this is your vector going in this direction. And we want to find alpha. So alpha is the inverse tangent of b over a, which is 19 over 46. And again, it's very important that you ignore the negative on the 19, especially when you're doing the inverse tangent. So inverse tangent of 19 over 46, the calculator will give you 22.4. So that's telling us that the degree measure inside this triangle is 22.4 degrees. Now that is not theta. Theta starts at 0 and rotates all the way around counterclockwise and stops in quadrant 4. So that means theta would be 360 minus the 22.4. And that'll give you 337.6. So that's the theta that you're looking for. All right, here's number 14. We have the vector 6i plus 17j. And again, we want to find the magnitude and the direction. Magnitude first is the square root of 6 squared plus 17 squared. And that gives you approximately 18 when you put it in the calculator. Okay, now for the direction, we draw a triangle. 6i means you go to the right 6 from the origin, and then 17j means you go up 17. We draw this vector from the origin out to this point, and we have this angle here inside the triangle. That's going to be our alpha. So alpha is the inverse tangent of b over a, or 17 over 6. We put that in a calculator and get 70.6 degrees. That is our alpha. And it just so happens that theta would be equal to alpha in this case, because this is in quadrant 1, and you're rotating from 0 up to where you stop in quadrant 1. So theta is equal to alpha. And so theta is also 70.6 degrees. And number 15, we're asked to find a unit vector. The formula for the unit vector is the original vector v divided by the magnitude of vector v. So here we have vector f, and vector f is denoted as negative 3i minus 11j. So here it says we want to find the magnitude first. So the magnitude of f is the square root of a squared plus b squared, or the square root of 3 squared plus 11 squared. And yes, I did ignore the negative on the 3, and I ignored the negative on the 11. And that's okay. All right, so now we have 3 squared plus 11 squared, which is 9 plus 121, which gives us 130. So the magnitude is the square root of 130. And then step 2, it's the vector divided by its magnitude, and I should have f there instead of v. Okay, that's vector f. All right. So vector f divided by its magnitude is negative 3 divided by the square root of 130 I minus 11 divided by the square root of 130 j. And of course, we can't leave radicals in the denominator. So after multiplying the top and bottom by the square root of 130, we get this bottom line here. It's negative 3 square root of 130 over 130 I minus 11 square root of 130 over 130 times j. All right, so vector f is negative 9 comma negative 6. We want a unit vector in the opposite direction of f. All right, so first of all, the vector that's in the opposite direction of f is simply the original vector with all the signs changed. So the 9 becomes positive, and the 6 also becomes positive. So the opposite direction vector would be 9 comma 6. And now to find the unit vector, we find the magnitude of f, which is the square root of 9 squared plus the 6 squared, which is the square root of 81 plus 36, which is the square root of 117. And then to actually find the unit vector, it's the original vector f divided by the magnitude of f. So that would be 9 divided by the square root of 117, comma 6 over the square root of 117. And then we have to get the radical out of the denominator, so we end up with 9 square root of 117 over 117, comma 6 square root of 117 over 117.